The world's largest dam was built to tame one of Asia's most dangerous rivers, generate enough electricity to power entire provinces, and stand as a monument to engineering ambition. Yet decades after its construction began, questions continue to follow the massive concrete barrier stretching across the Yangtze River in central China. Why do reports of landslides continue to emerge around the reservoir? Why have satellite images sparked repeated debates about deformation and structural movement? Why has a project designed to control nature become so closely associated with concerns about the very geological forces it was meant to manage? The Three Gorges Dam remains one of the most consequential infrastructure projects ever undertaken, not because it is collapsing, but because the immense scale of the structure has created challenges that continue to evolve long after completion. Towering approximately 601 feet high, or about 185 meters, and extending roughly 7,660 feet across the Yangtze River, or about 2,335 meters, the Three Gorges Dam dominates the landscape of Hubei province. The reservoir behind it stretches hundreds of miles upstream, transforming entire valleys into a vast inland waterway. Designed to control devastating floods, improve river navigation, and generate enormous amounts of hydroelectric power, the project reshaped one of the most important river systems on Earth. NASA has described the structure as the world's largest hydroelectric power project and documented how the rising reservoir dramatically altered the appearance of the region when compared with satellite imagery taken before construction. The origins of the dam reach back decades before construction actually began. Chinese leaders had long sought a solution to the Yangtze River's destructive flood history. Throughout the 20th century, catastrophic flooding repeatedly devastated communities across central and eastern China. Official estimates attributed hundreds of thousands of deaths to major Yangtze floods over the previous century. The idea of constructing a massive barrier capable of regulating the river's flow gained support as China's industrial and economic ambitions accelerated. Construction officially began during the 1990s and continued through multiple phases. The scale was almost difficult to comprehend. Millions of tons of concrete were poured. Entire mountainsides were excavated. New roads, bridges, power facilities, and navigation systems emerged around the construction zone. The reservoir gradually expanded as water levels rose behind the growing structure. By the time the project reached completion, the landscape visible from space had changed dramatically. NASA satellite observations documented tributaries expanding, valleys flooding, and the Yangtze widening far upstream from the dam itself. The benefits were significant. The dam became the largest hydroelectric power station on the planet, capable of generating enormous quantities of renewable electricity. Navigation along the Yangtze improved as larger vessels gained access to inland regions. Flood control capacity increased substantially, providing protection to heavily populated areas downstream. Supporters viewed the project as proof that engineering could overcome some of the most persistent challenges presented by the river. Yet even before completion, concerns emerged regarding environmental consequences and geological stability. The creation of the reservoir required the relocation of more than 1 million residents. Vast areas of land disappeared beneath rising water levels. Historic sites, cultural landmarks, and ecological habitats were permanently altered. NASA noted that hundreds of square miles of territory were submerged as the reservoir filled, fundamentally transforming the region. The greatest long-term concerns, however, increasingly centered on the landscape surrounding the reservoir, rather than the concrete structure alone. Mountains that had stood above flowing river valleys for thousands of years suddenly found themselves bordering an artificial lake whose water level could rise and fall dramatically. Slopes that had developed under one set of geological conditions were now exposed to entirely different pressures. As water infiltrated rock layers and soil deposits along reservoir banks, stability conditions changed. Some slopes weakened, others began moving slowly. Landslides became one of the most persistent challenges associated with the Three Gorges region. Researchers examining the reservoir area have repeatedly identified landslide susceptibility as a major geological concern. Studies focusing on the Three Gorges Reservoir area continue to analyze slope failures, hazard mapping, and the factors contributing to ground instability. Reports documenting thousands of landslides and seismic events in the years following reservoir filling further intensified attention on the area. NASA summarized findings from a 2010 study that linked reservoir operations with approximately 3,400 earthquakes and numerous landslides between the middle of 2003 and 2009. While many of these events were relatively small, they demonstrated how the introduction of a massive body of water could influence local geological systems. Reservoir-induced seismicity is not unique to China. Around the world, scientists have observed instances in which large reservoirs alter underground pressure conditions. Water penetrating deep fractures can affect fault systems and influence seismic activity. In the case of the Three Gorges region, the enormous scale of the reservoir amplified concerns because of the sheer volume of water involved and the complexity of local geology. Questions about sediment accumulation also emerged. Rivers naturally transport enormous quantities of sediment downstream. Dams interrupt this process by trapping much of that material behind their walls. Over time, sediment buildup can reduce storage capacity, alter river dynamics, and create new management challenges. Changes in sediment transport downstream can affect ecosystems, navigation channels, and riverbank stability. NASA identified sediment accumulation among the continuing concerns associated with the project. Beyond geological issues, environmental impacts extended into surrounding ecosystems. Changes in water flow affected fish migration patterns and biodiversity. Altered hydrological conditions influenced wetlands and habitats throughout sections of the Yangtze basin. Researchers continued studying how reservoir operations affected ecological systems both upstream and downstream. One of the most controversial episodes in the dam's history emerged not from scientific measurements or engineering reports, but from satellite imagery visible to the public. During 2019 and 2020, images circulating on social media appeared to show the dam bending or warping. The photographs spread rapidly across online platforms. Some users claimed the images revealed catastrophic structural deformation. Others argued that the dam was in danger of failure. The images appeared alarming. Instead of displaying a straight concrete barrier, some views showed a structure that looked visibly curved. Given the scale of the dam and the hundreds of millions of people living downstream, the photographs generated intense discussion. The apparent distortion quickly became the subject of technical scrutiny. Analysts pointed out that the images originated from mapping platforms that rely on mosaics of satellite and aerial photographs captured at different times and from different viewing angles. Organizations examining the imagery concluded that the apparent bending did not represent actual deformation of the dam. Instead, they attributed the effect to image stitching and processing artifacts. One review explained that Google Earth imagery often combines multiple photographs into a single composite, creating distortions when alignment algorithms encounter large man-made structures. The controversy became significant enough that Chinese authorities publicly addressed the issue. According to reports cited by Reuters, officials from China Three Gorges Corporation stated that the dam remained structurally sound. They acknowledged movements measuring only a few millimeters, resulting from factors such as water levels, temperature changes, and gravity distribution, while emphasizing that these values remained within normal engineering limits. Subsequent statements also pointed towards satellite imaging distortions rather than actual large-scale warping. Online discussions reflected widespread confusion. Some users interpreted the images as evidence of impending failure. Others noted that nearby structures exhibited similar distortions, suggesting image processing errors. Several commenters observed that if deformation of the magnitude visible in certain images were real, severe structural damage would already have been apparent. Discussions across engineering forums and public communities repeatedly returned to the same conclusion. The dramatic curvature visible in some screenshots was most likely an artifact of satellite image stitching rather than physical bending of the dam itself. That clarification did not eliminate broader questions about deformation altogether. Large dams do move, In fact, engineers expect them to move. Massive concrete structures expand and contract as temperatures change. Water pressure varies throughout the year. Reservoir levels rise and fall. Foundations respond to stress distributions that evolve over decades. The critical question is not whether movement exists, but whether measured movement remains within design expectations. For a structure of this size, monitoring never truly ends. Engineers continuously track displacement, stress, seepage, temperature variations, and numerous other indicators. Dams around the world are designed with the understanding that small movements will occur. The challenge lies in distinguishing ordinary behavior from signs of structural deterioration. The Three Gorges Dam faces another complication that many smaller dams do not encounter. Its reservoir occupies an immense mountainous region characterized by complex geology. Seasonal water level fluctuations expose slopes to repeated cycles of saturation and drying. Some observers have argued that these changing conditions may contribute to continuing instability in certain areas surrounding the reservoir. Discussions among online communities frequently point to landslide risks as a more realistic concern than the dramatic collapse scenarios often promoted on social media. Weather patterns introduce additional pressures. Intense rainfall events periodically raise concerns regarding reservoir management. Operators must balance competing objectives, maintaining flood control capacity, generating electricity, supporting navigation, and ensuring structural safety. During periods of exceptional rainfall, reservoir levels and discharge rates become subjects of close attention both inside and outside China. Satellite monitoring has become increasingly important in assessing these conditions. Modern remote sensing technologies can detect subtle ground movements across large geographic regions. Researchers use advanced methods to analyze terrain deformation, monitor landslides, and track environmental changes throughout the reservoir area. Scientific studies continue employing satellite data and machine learning techniques to evaluate landslide susceptibility and monitor evolving geological hazards. The scale of the Three Gorges project means that even routine operational challenges attract global attention. Few infrastructure projects influence as many people. The Yangtze River Basin supports major industrial centers, agricultural regions, transportation networks, and densely populated urban areas. Decisions involving reservoir levels can affect communities hundreds of miles away. International fascination with the dam often stems from its symbolic status. It represents both extraordinary engineering achievement and the limits of human control over natural systems. Supporters highlight its electricity production, flood control capabilities, and navigation benefits. Critics emphasize environmental disruption, displacement, geological instability, and long-term maintenance challenges. Both perspectives are rooted in realities visible throughout the region. The phrase that the dam is falling apart captures public anxiety but does not accurately reflect available evidence. There is no verified indication that the structure is undergoing catastrophic failure or approaching imminent collapse. The more complicated reality involves a massive infrastructure system operating under constant pressure from geological, environmental, and hydrological forces. The concerns surrounding the project arise not because the dam is visibly disintegrating, but because maintaining a structure of this magnitude requires perpetual management of risks that can never be entirely eliminated. Those risks remain substantial. Landslides continue to be monitored. Reservoir-induced geological effects remain subjects of scientific research. Sediment accumulation presents ongoing operational challenges. Environmental impacts continue to evolve decades after construction began. Climate variability introduces additional uncertainty regarding future flood patterns and water management demands. The Three Gorges Dam was designed as a permanent solution to some of China's most persistent water management problems. Instead, it became part of a much larger and continuing relationship between engineering and the natural environment. Every rise and fall of the reservoir, every slope movement along the shoreline, every sediment deposit trapped behind the wall, and every debate sparked by satellite imagery serves as a reminder that large-scale infrastructure projects do not reach a final state of completion. They enter a continuous process of adaptation. Satellite images that once appeared to show a warped structure ultimately revealed more about the limitations of imaging technology than the condition of the dam itself. Yet the controversy endured because it tapped into a deeper concern. The public was not merely reacting to a distorted photograph. People were responding to the realization that the world's largest dam exists within a landscape that remains active, dynamic, and sometimes unpredictable. Today, the Three Gorges Dam continues generating power, regulating river flow, and supporting navigation across central China. At the same time, scientists continue mapping landslide hazards, tracking environmental changes, studying seismic activity, and monitoring the reservoir's long-term effects. The structure stands as one of the most closely watched engineering projects on Earth. Its future will likely be defined not by a single dramatic event, but by decades of ongoing management. The real challenge facing the Three Gorges Dam is not whether it can survive tomorrow. The challenge is whether a project built to reshape an entire river system can continue adapting to geological, environmental, and climatic pressures that will persist for generations. The dam remains standing, functioning, and heavily monitored, yet the questions surrounding its long-term consequences have never fully disappeared. That continuing uncertainty, rather than any viral satellite image, explains why the Three Gorges Dam remains one of the most debated infrastructure projects in the modern world.